Okay, so we see that the ideal gas law depends on three things: the number of molecules, temperature, and volume. And so now we want to go in and we want to look at these guys. So here we go. Is that what I want to look at now is I want to look at the number of molecules and pressure. So according to the ideal gas law, what we're seeing here is that the ideal gas law reads like this. So the gas pressure is then going to be proportional, and what we're going to look at is the number of molecules. And this is the only thing that I'll focus on, but remember, we also have the temperature of the gas, and we also have the volume of the gas. And we're focusing only on the number of molecules. So here we go. So remember what I said here. And one of the things that I said here is that I said that when I look at anything about the gas pressure, you always got to ask yourself the following questions. How does changing any parameter increase or decrease collisions? That's the thing that we're always asking. If it increases it, okay, let's say that if it increases it, then there's an increase in pressure. If we decrease the number of collisions, then we decrease pressure. That's all we want to pay attention to. So let's go to the ideal gas law. I'm going to add particles here. So here I go. I'm going to pump them. And what you're seeing here is that I have a number of gas particles, and you could see a couple of things. There's a couple of things that's important to note here, is that the only pressure we care about is on the walls of the container. The collisions between the gas molecules does not matter. So what you're going to find here is that look at the gas pressure. You see how it's not a constant value? And that's because this is a random gas. Sometimes more particles collide with the walls of the container. Therefore, there's a slight pressure increase. And then sometimes there's less number of collisions with the walls. And therefore, the pressure drops slightly. So the only thing we typically care about is a particular type of average. It's known as the RMS value. It's known as the root mean square motion. And that gives us something like an average that actually does that. So now that I have that, one of the things that I want to do here is that I want to go in and I want to sort of like start to look at some of these other things here. So now, here we go. So if I look at this thing, I want you to pay attention to the pressure. So you can see that the pressure right now is about, let's say 29.5. Let's say that's the average. So if I look at the number of particles, do they tell me the number of particles? Right now, there are 252 light particles in this thing. So what I'm going to do now is that I'm going to add particles, okay? And this is a collision counter. So it tells you some details about the walls with the container. But check this out. Look what I'm going to do. I'm going to pump more gas molecules. Look at the pressure gauge. So if I do this, I'm going to pump in more. You could see me pumping in more. And look what happened to the pressure. It increased, right? It increased. So now I have a higher pressure. So what I'm going to do here is that I'm going to go back into my OneNote and start writing some stuff down. So if I look at my OneNote, here's what we say. What we find here is that we see this. We clearly see that if I look at the, what we find here is that if I look at the gas pressure, right? Here's the gas pressure. And what we're seeing here is that, of course, this is proportional to the number of molecules. But now I want to branch off. So note that when I had more particles, I had more collisions. And because I have more collisions, I created a higher pressure. And that was exactly what we expected. And then if I had less particles, that means I had less collisions, so therefore I had a lower pressure. So the question now is this here. Question is this: how does one create a low pressure region? Right? How does one create a low pressure region? So let's go back to the applet. So if I go back to the applet, we're right in here. So check this out. If I want to reduce a high pressure to a low pressure, we clearly see that we have to reduce the number of molecules. So there's this handle here, and this handle allows me to open the container. So what am I going to do? I'm going to remove particles. Look how the pressure is dropping. As the pressure is dropping, you're seeing that I went to a lower pressure because I removed gas particles from the system. That's how I got a low pressure. So let's go write this up. So what we're seeing here is that the only way we know how to create a low pressure region is that we got to come in and what do? We remove gas particles from the container. And that's exactly what the ideal gas law says.